Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. Today we are looking at a red topic, memory and storage. Pause the video to take time to reflect on what you know so far. Fill in the ticket in your green book. So in our last video, we learned that RAM and ROM are primary memory. In this video, we're looking at secondary storage, and the hard disk is an example of secondary storage. On my screen, I'm showing you RAM and the hard disk with contents, and the power is on. I'm going to remove the power. And when the power comes back on again, there is no contents in RAM. It lost its contents, whereas the hard disk kept its contents, which is very useful because we need our files to be there when we switch our computer back on again. So the hard disk is non-volatile storage. It doesn't lose its contents when the power is switched off. Secondary storage is needed for long-term storage of data and programs. It is non-volatile. We're going to learn about binary later in the course, but for now, binary is a number system that uses ones and zeros, and we're using that to store data. So we only need to store ones and zeros, and the smallest storage unit we've got is a bit, which will contain a 0 or a 1. The technology that we use then needs to be able to represent these ones and zeros. And we need to look at a pattern that we can convert back to ones and zeros. So we'll need to have the technology set up, or to be able to be set up in one of two states. We're going to look at how that is achieved in optical, magnetic, and solid state technology. So we're looking here at DVDs, Blu-rays, and CDs. And one thing I want to mention is the use of the word media and also device. Now, media are basically the devices that we are writing the data on, and the device itself is what that media is put into to be read. And sometimes that's the same thing. So that's why you will sometimes hear the word media and sometimes hear the word device. And sometimes you'll even hear the word medium, which is the singular for media. But right now, let's think about how optical technology can put a pattern on this disk that will actually have two states that can represent ones and zeros. Well, a laser beam burns a pattern into the surface, and it either burns a hollow or it doesn't. So when it burns a hollow, that's called a pit, and when it doesn't, that's called a land, and that gives our two states. Light is then shone on the disk in order to read it, and the reflection that comes back is used, and a sensor can detect whether or not there is a land or a pit, and that's a light sensor. So that's it for optical technology. They're quite low in capacity. Megabytes and gigabytes we will be learning about in our next video, but what you need to know right now is what can be stored on these disks is quite low, but they still have their uses. Magnetic technology. There's a number of ways that magnetic technology can be used to have a pattern, and the one that we are going to talk about is whether a unit, a small particle, is magnetized or if it's not magnetized. Now you could also talk about north and south polarity, and it doesn't matter, because as long as you give a method that shows you understand there has to be two states, that will be fine. But we're saying, is the unit magnetized or not magnetized? That gives us our 1 or our 0. It's interesting here looking at the hard disk, because it's got inside it moving disks that they're rotating, and they've got a magnetic film over them that can have these little particles that are either magnetized or not. And then they've also got this arm that is doing the reading. So that's moving back and forward, and there's a head at the top that's actually reading the data. So that's an example of the media and the device all combined together. Here we've got a magnetic tape, and that's quite often used for backups because it can store a large amount of data, and it's not that expensive for the amount of data that it can store. We're talking terabytes of data there, if I didn't already mention that. Solid state technology is our final technology that we're looking at, and it's also called flash technology. So you might call your memory stick a flash drive. You might also call it a USB drive or a USB stick. Now, if you just call it a USB on its own, you won't get credit for that, because USB is a protocol. So the exam board needs you to say USB stick. A camera could have a solid state card to store videos and photos. And this laptop could have a solid state internal hard drive, which is more sensible and practical in a portable computer because it won't have moving parts and it's quite light. The technology then has got electronic NAND gates, and you don't need to know about NAND gates for now. We'll be looking at them in another video. What you do need to know is NAND gates can store a charge, and if there's a charge there, that could be a 1, and if there's not a charge there, that could be a 0. So that's how solid state technology works. The next part of this video is thinking about which device we would choose for which job. There are 6 key words you need to be using when you're talking about them, so I'm going to show you them straight away. And for example, if you wanted to choose a device to back up your files at home, the things that would be probably most important to you here will be capacity, how large a file or files that the device could take, so how much do you need to back up. Cost is probably important to you. Portability, unless you're bringing it somewhere, that wouldn't be important. Speed, you probably manage with speed of any device really for backups, because you're probably just doing them once a day or once a week. Reliability, you definitely need it to be reliable, and reliability here means how that device will work after being used over and over again. And finally, durability might not be important because you're not moving it around, but durability really is how many knocks it can take, how tough it is, what will happen if it gets a scratch. I would suggest now that you pause the video and have a go at filling in this table. So you're basically rating one device over the other based on these different criteria. And now I'm going to put up the answers. So here, for me, it was very difficult to actually put a tick here for capacity for the hard drive to win over a solid state disk, because both can actually have a huge amount of data. Clearly, though, solid state wins out on speed, portability, and durability. And these two together, really, there's no moving parts in a solid state disk. There isn't the hard drive. So it's safer to carry around something that hasn't got moving parts. There's less that can go wrong. And durability also, because of not having the moving parts, I've voted for the solid state disk. Both I feel are reliable, although you will find some textbooks that will tell you that a solid state disk can only be written to so many times, but the reality is we never seem to get to that many times. You know, we haven't been let down. Well, I certainly haven't been let down by my solid state devices. My tablet, for example, that's always been fine and I've had it for years. Cost, and the magnetic hard drive, for the amount of storage space that you were to get, it's cheaper for the magnetic hard drive. Okay, so again, pause the video and have a go at this one. I'm just about to reveal the answers. So we're looking at solid state disk versus memory stick. Now I've deliberately put solid state disk in 2 different tables as a comparison. For example, you can see here it doesn't win on portability now, the memory stick does, because both of them have no moving parts, both of them are light. However, the memory stick tends to be much smaller, so it makes it more portable. And that's not to say that the solid state disk is not portable, it's just in this comparison, it's not the most portable. So it really is important when you're reading questions on this to recognize what you're comparing, or if you were just asked to recommend devices on the basis of portability, you could say a solid state disk and a memory stick. You could say a CD. Lots of them come out as good examples on that. Right. Solid state disk, although it's using the same technology as a memory stick, the speed is faster. So it's engineered faster. Capacity, solid state disk typically has a lot more capacity potential than a memory stick. But memory sticks now, I've seen one today on Amazon and like it was 1 terabyte. So that's changing. Durability, they're both durable, and reliability, as I say, I feel they're both reliable, so I tick both for that. And cost, well, it's no surprise when the solid state disk has got a bigger capacity and faster that you would be spending more on that. So the memory stick is better if you're concerned about cost. And one more, and this time we're looking at optical technology. We're comparing a CD, which can be read and written to a DVD, which can be read and written to. So I am going to show the answers. Now it's important to remember here that all optical technology are slow. The CD is the slowest, then the DVD and the Blu-ray. So the DVD will be much slower than memory stick. However, when we're just comparing it with a CD, it is faster. It has got a lot more capacity and it is faster. Portability, both of them get a tick there because they can be carried around quite easily. You can put them in their case, protect them from damage. Durability, they are easily scratched, easily broken, so they don't get a tick there. They're both reliable. However, it's no surprise that the CD is coming out cheaper because it hasn't got the potential to have as much capacity or speed. Finally, let's look at 3 different scenarios. So I'd like you only to tick one box for each of these. So if you tick tape once, you can't use it again, and have a go at that. Okay, I'm going to put up the answers. Right, so the obvious devices for each of those scenarios are memory stick, tape, and DVD. I hope you got that. So obviously, as a student, of those 3 devices, the memory stick is the most portable, and it ticks all the other boxes too for what the student needs. For an IT manager, they really are concerned about capacity to back up all of the company's data. Now, if there was a column here that said solid state hard disk, well, you could have put the tick in that or this, and both answers would have been correct. So for each scenario, there's not always one right answer. There could be more than one right answer. And distributing a movie, well, a DVD would be ideal for that. It's not too expensive. A film would fit on a DVD. It's quite easy to package up and send out and distribute. So a DVD would be well suited to that. What have we learned? We've learned about optical, magnetic, and solid state storage. And for each of them, we learned how there can be a pattern that would then represent our ones and zeros. Laser beam technology is used for optical. Whether or not a storage unit is magnetized is used for magnetic, and electronic NAND gates are used in flash technology. We've also learned that we might have to recommend a device for a particular scenario, and there are many devices, and sometimes in a particular scenario, one or more of those devices would be acceptable. We need to be using these keywords though when we're comparing them, and that's important. So that's it for secondary storage. There has been a lot in this topic. I hope you found it okay. Do go back over the video if you're not sure. Bitesize also has got a really good table on secondary storage, comparing all the technologies and the media and also comparing them against all the criteria. So it's well worth a look at if you need something else to reinforce your learning. But that's it for secondary storage. I hope you've enjoyed the video. Don't forget to fill out your green slip in the back in your book. And that's it.